Before I use any specific terms, so I mean, now I'll give you a specific way of handling simulations, and this will be called as the robot operating system. That's also the simulation framework where we will be doing all the lab exercises now on. So we'll be making use of this framework. Now, firstly, it's not an operating system. It is a software that runs on the Ubuntu operating system, typically Ubuntu. So it's not actually an operating system. Now, the term operating system is derived from the fact that what does the operating system really do? The operating system gives you a software interface where you interact, and the operating system interacts with all the resources, all the hardware, and everything that is there, which is on place. And that's exactly what I say, that I have all the different libraries around. I've got all the different services around. I've got all the different real robots around. I've got all the different simulators around. I've got all the different simulated robots around. So it gives me a mechanism by which my scripts and each one of these scripts, each one of these entities can interact with each other. They can share information, they can send information, they can derive inputs and outputs from each other. And that's why you call it as the robot operating system. So essentially the problem that I need to solve is exactly the same, that there is a vision camera. And the vision camera gives data in the form of an image to a lot of modules, and one of the modules is, say, the localization module. Easy enough. And the problem is that the vision camera may be at some system and the localization system may be at absolutely another system. Now, in general, anybody who gives data, we call it as the publisher. And anybody who gets data, we call it as the subscriber. So the name is derived from classic literatures, which is also what we do. So you read absolutely great articles for your research. And how does that happen? So IIIT Allahabad in specific, and you people in specific, have registered to mailing lists of all the journals. So the journal publishers, they publish journals, they publish articles, and they give you a call back in the form of an email, and you get the email and you start reading all the journal articles. So those are the publishers and we are the subscribers. They give data and we consume that data. Classic example, so lot of information now comes on Twitter. So this is your favorite news agency. So your favorite news agency, it publishes through tweets data, and you consume that same data. So those are called as publishers, and that's why you call as subscribers to that Twitter channel. Similarly, you have famous celebrities. They give posts on your favorite social media. You subscribe to them, you follow them. So they write data and you consume that data. So they're the publisher and you are the subscriber. Now, let's talk about two things. Firstly, for your favorite news channel, you are not the only subscriber. I am also a subscriber, and so is the friend of mine. We subscribe to the same channel, and that's how I will show it. So I'll say image, and we all subscribe to the same channel. So what really happens is that the famous celebrities will only have one tweet, will only have one Instagram story, will only have one Facebook story, and we all are subscribed to that. So we all have contacted the Twitter event manager. So we all called up Twitter event manager and said that we need to subscribe to famous celebrities this Twitter channel, and they said, okay, I accept you as a subscriber. And the famous celebrity, it said that I want to publish to this channel or this Twitter handle, and the Twitter event manager said, okay, then whenever the celebrity tweets, the Twitter event manager lets each one of us know, and that's what we get as notifications. In programming, a registered function is called. So the function that I register is called as the callback function. A function registered by the subscriber that is automatically called when the channel is called as a topic when the topic gets new data. So, and there's information sharing. The celebrity need not tell me separately, tell you separately, tell my friend separately. The celebrity just tells Twitter event manager, and the Twitter event manager lets each one of us know. So there's information sharing. Now, what really happens is that the frequency of publishing and the frequency of consuming may not be the same. So say this is 10 hertz, this is say 5 hertz, this is 100 hertz, this is 25 hertz. So this works a lot faster than this works a lot slower than this. And therefore what will happen is that here data is getting produced as a larger rate, it's getting consumed at a smaller rate, and therefore a queue will get formed. So this vision camera is putting things inside this queue, and the queue is being read by the potential field. And because the rate of inflow is large and the rate flow of outflow is large, either the queue will increase with size, or you can set the maximum queue size. So data will be deleted, all the data will be deleted. There will be some data which will not be used, which is natural because potential field is operating at a smaller frequency than what your vision camera is giving you. So there will be loss of data. And because there will be loss of data, so some data will not get consumed at all. It will be a part of the queue, but then the vision camera will try to add new items into the queue. The queue will be full and those items will be rejected, and the oldest data is the one that will be deleted in order to accommodate them. So the data will be lost. Here, absolutely no loss of data can be there, but here there are two options. So depending on how you program it, so either this module will wait for new data, and sometimes we program it that decision is made by using LiDAR alone. So vision camera may not be always used for localization. Sometimes you may localize only based on LiDAR, and then whenever vision camera is there, you may use it for whatever you can, but your immediate decision making may be without vision camera. So both things are possible. Sometimes you wait for the data when data is invaluable, and sometimes you say that let me make in my decisions in the absence of the data by guesswork. Whenever the data comes, I'll rectify my decisions and I'll act accordingly, but I'll not let the frequency low down because my input data is at a smaller frequency. I'll not wait for my input data. And that is how I actually handle things up. Now, it's possible that this thing is physically as system 1, and this thing is physically as system 2, and this thing physically is as system 3. So you need a protocol for information exchange, and the protocol is called as a ROS TCP, which is of course the TCP and a ROS wrapper around it. So the ROS wrapper around it ensures that the headers and the way it's handled is ROS specific, and of course it tries to make it faster. So summarizing it up, this image has gone a bit dirty. So I say that there is a publisher, there is a subscriber, and every subscriber registers to one or more topic over which it is interested, and the publisher publishes on that topic. There's an event manager whom subscriber is registered to with a callback function. So whenever data comes, a callback function is automatically called. The publisher publishes to this topic, and whenever it publishes to this topic, the event manager gets to know about it. The publisher tells the event manager that I published new data to this topic. So subscriber will not have to ping the topic or the publisher again and again. The callback function will be automatically called. That's how we do event handling. That's all GUI. All GUIs are handled like that. The data of a specific message type will go. It could be integer, it could be string, it could be doubles, it could be custom classes, but then all data with respect to a message type will go. And that's also important because you know that eventually there's a physical media, there's a physical channel, these could be different system. So whatever data goes will have to be appropriately converted into actual objects, and that's how the binary to object conversion takes place, the way data is accessed, and that depends upon this message type. So it could be integer, it could be string, it could be anything, custom class. Publisher for something could be consumer for something else. Let's take it as an example. So the localization system, it wrote to a topic pose, and the topic pose was, of course, so the squares are the topic and the circles are the scripts or the nodes. So these are called as the nodes, which are physical scripts, which are programs. So localization topic wrote to a pose, and of course the planning topic read from the pose, but then the localization system itself read from a LiDAR sensor. So if you talk about localization, which is a physical script, is a publisher to pose. However, localization is a subscriber to topic LiDAR. So the same node could be a publisher to one or a subscriber to other. That's actually interesting because one of the most naive question I get in robotics is that how do you take inputs and outputs? Is there a keyboard attached to robot? You say enter any number N, enter A, enter B. No, we all take it from networking channels. So the manufacturer gives us some scripts running those. They are networking channels and ROS which are created, and if we need input, we just take it over a networking channel. So all inputs come from a networking channel, and everything goes into a networking channel. It could be more interesting because sometimes you will actually get in cycles in this graph. So the localization system may actually try to predict using motion models that where is the robot, and one of the way you can do that is making a planning. So I say pose predictor, and that completes a cycle, and because there's a cycle it's a graph, and this graph is called as a ROS graph. So a ROS graph is a graph where the vertices are, these are the vertices, these are not the vertices, these are edges. So where the vertices are nodes, which are programs, which are scripts, and the edges are topics. So these are the edges, the topics, and these are the nodes, which are the vertices. And the ROS graph, it tells you all kinds of information interchange between any two nodes. What is it taking as inputs? What is it giving as output? What does it depend upon? What does it give as output? All the information exchange between the different scripts is what is done by a ROS.